Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel and it helps us reach others in need of assistance with these topics. So what we're going to be covering in today's video is we are going to be going over calculus-based physics, and we're going to be introducing one-dimensional motion. Now, we won't be going over any examples or problems in this particular video. This is more of an explanation of how to find certain parameters such as velocity, acceleration, and other properties and parameters for one-dimensional motion in calculus-based physics. All right, so let's get going here. So calculus-based motion equations for one-dimensional motion, we have velocity, we have acceleration, we have net displacement, and we have change in velocity. So we have four things that you can possibly find in this one-dimensional equations, or these one-dimensional motion equations. So let's start with velocity. So velocity is denoted as v sub x, and it is a first derivative of the position x with respect to time. Now, x will always be a linear position. It will always be a straight line because we are dealing with one dimension here. So x will be at its beginning, which is usually typically labeled as x sub o. So anytime you really see the o or the zero there, that's the initial, it means initial. So this would be our initial placement, and then this would be where we are looking at our position of x along that line. So your velocity equation, v sub x, would just be the first derivative of your position x with respect to time. Now, your position x will be an equation that has t in it. Now, it could be like t cubed minus 9t or something like that. It will always be an equation based upon time because you are moving in a position relative to how much time you're spending in that position. So the velocity equation v sub x will just be the first derivative of the x equation with respect to time t. Alrighty, so scooting on down here, acceleration. Acceleration will be abbreviated as a sub x, and that is the first derivative of your velocity with respect to time t. Acceleration is also the second derivative of your position x with respect to time t, because, well, velocity is the first derivative, and then you're taking another derivative of your velocity, thus it will be the second derivative. So your a sub x, which is your acceleration, would be your derivative of your velocity with respect to t, or it is your second derivative of your position x relative to your, or with respect to your time. So that's what acceleration is. Once again, your v equation will come out in some terms of t. So maybe like vx is equal to 9t squared plus and minus something, and then your acceleration will be based upon that. Net displacement. Net displacement is shown as delta x. Pretty much anytime you see a delta that is representing displacement or change in position, is the definite integral of the velocity v sub x over time. Please note that net displacement is a straight line from the initial position to the final position. Very similar to what I wrote earlier, that you would have your initial position and then your final position. Well, that difference there is delta x. Well, your delta x, you could write it as this or find it like this. It would be your definite integral from your initial time to whatever time you're specifying of your v sub x equation, delta t. Well, because what is v sub x? V sub x is the first derivative with respect to time of your x position. So working backwards, you would take the integration of your velocity to get to your x equation. All right. And the last one would be your change in velocity, which is represented by v sub x, your velocity, minus your initial velocity, because remember, little subscripts of 0 or O represent initial. So this is the definite integral of your acceleration over time. Therefore, the final velocity v sub x equals the initial velocity v sub O plus the definite integral of your acceleration a sub x over time. So basically, all this verbiage can be written like this, where you have v sub x is equal to your initial velocity vx0 plus the integration of your initial time to your time that you're specified at of your acceleration with respect to time. Alrighty, so those are the main equations that you're going to have for your velocity, your acceleration, your displacement or your net displacement, and then your velocity or change in velocity. All right, so what's the strategy here moving forward? Because with all of these portions here, you're not going to be given all of the information. You're going to have to use a lot of these equations in order to find your velocity, acceleration, or net displacements. So what's strategies here? Well, what I'm going to go over now is three different types of strategies given or starting with what you're given with and what you have to find. So each of these sections is going to have what you're given in red, and then it's going to talk about how to find the different items such as net displacement, velocity, or acceleration if you're given this amount of information at the start. So we're going to start with what if you're given your position x as a function of time? Once again, x could be something like 3t cubed minus 9t or something like this over time. So to find your net displacement, simply plug the final time into the position function of x of t, which is this right here, and then plug in the initial time into the position function to find xt0 and subtract the two results. So keep in mind here that this is not saying x times t, this is saying x of t, and this is saying x of t sub o. So you would plug in whatever time you're specified into this equation, and then you would plug in your initial time into that equation. So essentially, to get to the net displacement, what you're going to use is this equation. So it'd be delta sub x, which is your net displacement, is equal to your x equation when plugging in the time that it is specified at, the time in which you need, maybe like 5 seconds, 6 seconds in the future. And then you're going to subtract off the same x equation, but this time plugging in your initial time. So for instance, maybe your initial time is at 5 seconds, and you want to find out what your future position would be 10 seconds later. So this would be 15 seconds then. So that's how you would find your initial net or your final net displacement using your x equation there. All right, so moving on, let's say you need to find velocity. Well, in order to do this, you're going to take the first derivative of the function of the position function with respect to time, and then plug the desired time into the velocity function. So it's basically the same equation as before. Velocity is just v sub x, which would be equal to that x equation, finding the derivative of that x equation with respect to t. So basically, you would just dx dt, your initial position equation. So that's very simplistic. And if you needed a velocity at a certain time, you would plug in whatever time you needed. All right, so our third, if you're tasked to find with your acceleration given position, so this one you would just take back-to-back derivatives, so two derivatives of the position function with respect to time, and then plug in the desired time into the acceleration function. So your acceleration, a sub x, would just be the second derivative of that x equation with respect to time. And of course, you would get a is equal to maybe like 3t, for instance, and then you would just plug in t at 3 seconds. If you're told to find the acceleration at 3 seconds, you would just plug that in there, and whatever pops out would be your answer. So usually when you're given position, to find net displacement, velocity, and acceleration is not bad at all. It's one of the easiest ones. All right, so let's say you have a problem and you are given velocity at the start as a function of time. And let's say, for instance, this would look like you're given a velocity of equation of like 9t squared minus 16t or something like this. This is what you're given at the start. So let's say you're tasked with finding net displacement. Well, how would you do that? Well, you would find the definite integral of the velocity function over the desired time integral. So they would say, what's your net displacement when your initial time is 1 second and your final time is 4 seconds? So you're looking at how much you have displaced over 3 seconds there, from 1 second to 4 seconds. So in order to do this, you would just use this equation of delta x, which is your net displacement, and you would just look over the definite integral of your initial time to your final time, of that equation v sub x with respect to t. So you would just integrate this equation with respect to t, and then plug in your boundary conditions here of t sub o and t. And that would pop out your overall displacement amount. Okay, not terrible at all. So to find the velocity, this is very simple. To find the velocity, just plug in your specified time into the velocity function. So it would say, what's your velocity at 4 seconds? Well, you would just plug in 4 seconds into this equation, and whatever pops out as your answer would be the velocity at that time. All right. So let me get all that in there. There we go. So to find the acceleration, if you're given velocity, you just take a derivative of your velocity function with respect to time and then plug in the desired time into the acceleration function. So keep in mind that your acceleration is just the first derivative of your velocity function with respect to t. So what you would do is that you would just take the derivative of this function, and then you would just plug in whatever time it is asking for. So if it says find the acceleration at 5 seconds, well, you would just take this derivative and then plug in 5 seconds, and that would be your acceleration at that time. So that's what you would do if you're given velocity. Not very bad at all. All right, so let's move on. And let's say this time you're given acceleration, a sub x, as a function of time. So once again, this may be something that looks like, let's see, it's 18t plus 16 or something like this. Some kind of function with respect to time. So in order to find your net displacement, you first have to find the velocity. So let's go down here and let's see what happens. So to find the velocity, you first find the definite integral of the acceleration function over the desired time interval, and then add the results to the initial velocity. So typically when you're given an acceleration problem, you're going to be given the initial velocity here, because you have to know how fast you're going at the start. So to find your final velocity, or your velocity at that specified time, it's going to be v sub x is equal to vxo, or vx0, your starting velocity, your initial velocity, plus the integration of your initial time over the time that is specified of your acceleration with respect to t. So this would be your overall velocity after plugging in your whatever time you're specified here. So once you found this, now we can go back up here into your net displacement. So we did the first step, we found the velocity. Then find the definite integral of the velocity function over the desired time interval. And it says here, be sure to use the velocity function, not just the numerical value. Because with this one, if you're finding the velocity, you're going to get some value, maybe like 21 meters per second or something like that. Well, you don't want to use this one in your integration. You want to use the overall integration here. So it would be like this, where your net displacement would be the integration of your velocity function, the function with respect to t, from your initial time to the time that is specified. Do not just take the initial value, or not the initial value, the final value that you have for v sub x. You need the function in here for v sub x. So your v sub x has to be in terms of t. It can't just be some solid value. So that's very important, because I see that mistake a lot. You got to make sure that it is the function you're taking the integral of, not just the numerical value. All right, and then lastly, if you are given acceleration, well, how do you find acceleration? Similar to when you were given velocity, how do you find velocity? Well, if you're given acceleration and you need to find acceleration, simply just plug in your specified time into your acceleration function. So if we were given this value right here, and it says, what's the acceleration at 4 seconds? Well, you just plug in 4 seconds for t, and whatever value pops out, that would be your acceleration for that time. So that's how you would do calculus-based physics for one-dimensional motion. You have to be given your net displacement, or not your net displacement, you have to be given a position, a velocity, or an acceleration. And if you're given one of those three, you can find the other two. So for instance, what we just saw, if you're given acceleration, you can find velocity and the net displacement by integration. And then, of course, the acceleration by itself would just be plugging in your time that you are told. So I hope this video was helpful. And in the future, we will be posting actual physical examples of real problems utilizing these methods shown in this video. So just stay tuned for that because we'll be posting that soon. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us out. Thank you for watching, and I hope you have a fantastic day.